I think I am live. Can someone in the chat confirm me if I'm live and perfectly audible? Okay, let me increase the size. Can someone in the chat confirm me if I'm live and perfectly audible? Okay, hi. So you are audible. Everything is fine. Audio and video. Okay, cool. Okay, let me know if you hear any echo. I have a feeling that there is some echo. Okay, let me know if that's the case. Okay. All right. Anyways, we okay. What is this? Okay, system testing is going on. So we are going to solve problem A, B, C, and D of today's A, B, C, and D of code forces round 722. Let me open my editor. Okay, okay. Let me know if you hear any echo. I have a feeling that there is some echo. Okay, let me know if that's the case. Okay. All right. So let me just close all these, and I'm waiting for some people to join. We don't have many people joined yet. In the meanwhile, you can tell me like how many problems you were able to solve in the chat. Okay. Confirm says no, sir, no echo. Okay, cool. Okay. Okay. So what I'll do is, okay, I'll copy. I'll show my codes from the submissions only. Rajnish is, I think, little echo. So there is some voice. Okay, let me know if you hear that echo again. I have like cancelled that echo now. So only two problems. That's good, Nikhil. In today's contest, actually, B had some edge cases, so B was also nice. Okay, so it's good if you were able to solve two problems. Okay, solved only one problem. Anupam says that's perfectly fine, Anupam. Just keep practicing. Okay. Okay, okay, we have 17 people. Let's wait for a few more people to join. In the meanwhile, let me tell you a little bit about myself. My name is Naman. I am working as a software developer in Adobe. Before this, I was working in Shaw. I used to be a candidate master on Codeforces. Right now, I'm not. Apart from this, I'm a 5-star on CodeShip. And now let me introduce you to the Unacademy's subscription plans. Okay, so basically, we have 4 batches launched in this month. One is the interview batch, one is Samurai, Adroit, and Gladiator. I'll be telling you about all these batches in the meanwhile. Okay, so all these batches have already been started. And now, if you take an Academy subscription, through that one subscription, you will get all these batches. Okay, so let me just tell you like what all things you get in the batch. So basically, this is the course structure of the interview batch. I think this is for okay. This is for Samurai. Okay, so this is in week 1 we are going to do building blocks of programming and so on. Okay, so you can just read all these like whatever topics we are going to cover in every week. Okay, same for this. Then this is about the interview batch. Yeah, this is about the interview batch. These are some of the educators who are going to be teaching. As you can see, all of them are like some of them are ACM ICPC World Finalist and working in Facebook, Google, etc. These are the subscription plans. Now you can use my referral code as always. The referral code is NBYT. Okay, use this referral code to get a 10% discount. Okay, so that's about it. I think we can start solving the problems now. We have 22 people watching. That's okay. Okay, all right. So we are going to solve A, B, C, and D. So just okay, cool. Okay, let's start with problem A. In problem A, we are given that Okay, let me open standings. Okay, I have standings. Okay. So it is given that Ishaq has an array A consisting of n integers. Ishaq can perform the following operation any number of times. Choose some subsequences of A and delete every element from it which is strictly larger than average. Okay, where AVG is the average of the numbers. Okay, cool. For example, if A equals to 1, 4, 3, 2, 4, so our A right now is okay 1, 4, 3, 2, and 4. Okay, and Eshag applies the operation to the subsequences consisting these 5 numbers. Then he will delete those 4 elements which are larger than the average of this. Okay, so after the operation, the array will become 1, 3, and 2. Your task is to find the maximum number of elements Eshag can delete. Okay, so basically, there is an operation. In that operation, we remove values less than average, which are less than average. Okay, and we can do this operation any number of times. Okay, now he wants to know what are the maximum number of elements that he can remove. Okay, so let's do one thing. Let's try all the operations on this array. Right now average is 1 plus 4 plus 3 plus 2 plus 4 by 5. Let's see what is the sum. So we have 1 plus 2, 3, 6, 10, 14. 14 by 5 is actually 2.8. Okay, now we need to remove every element which is greater than 2.8. Yeah, which is greater than 2.8. Okay, why are then we will delete. Yeah, it was too hard. Some issues are okay. Is the question something else? Like containing A1, A2, A4, and A5. Then he will delete those of these 4 elements which are larger than. Okay, yeah, cool. So basically, average right now is 2.8. Okay, now he will delete every element which is greater than 2.8. So that is 3, 4, and 4. So after this operation, we will be left with 1 and 2. Now let's try to find the sum average of this. So average of this is actually 1 plus 2 by 2, which is nothing but 1.5. With this, he will delete this 2 as well, and in the end, he will be left with 1 only. Okay, and like average of 1 is 1 only, therefore this will remain. Let's look at in other test cases. Now, what if in the like very last step when we had 1, we had 2 ones? Average of this would still remain 1. Similarly, if we had, let's say, like 3 ones also, then also average of this would have remained 1 only, and all the 3 would have remained. Okay, so if you see now, if there are any number of, okay, let's look at the test cases. So if we have 1, 1, 1, 2, 2, 3, if you see in the end, because we are finding averages, so in the end we know that 1 will be removed in the end. If it is either ever removed, it will be removed in the very end. Okay, if it is removed in the very end, then we can say that, so basically if 1 is removed in the very end, then we know that before that 2, 2, 3 will be removed. Now if any element which is with 1 also, then average will become 1 point something, and that element will also be removed. So if you see in the end, only the minimum element will remain, because if we have the minimum element and then we have any other random element, then average will be a little greater than, so this will be greater than minimum, and every element greater than minimum will be removed. So in the end, we will only be left with minimum value. And if we have multiple minimum values, then all of them will remain. So all we have to do is we just need to find the count of the minimum value, and we need to like total size of the array minus that count is the answer. So if you see in this test case, we have 3 ones. Okay, so basically the total size is 6. So 6 minus 3 is 3, therefore answer is 3. Okay, now in this, if you see, 9 is the minimum element and every number is 9. Therefore 6 minus 6, because the count is 6, so 6 minus 6 is 0. Then similarly in this case, we have 3 ones and 1 is the minimum value. So total number of elements are 6. Minus 3 will again give us 3. So let me just show you the code. Okay, I hope this is clear to everyone. Okay, I need to show the code from standings only. Okay. Okay, if we look at the code. Okay. Let me just copy this. Okay, so this is the code. if you see what I've done is I actually made a map. Okay, and in this map I'm just adding the count of every value. Now since it's a map, we know that it will sort all the values. Therefore what I did was I actually did m.begin, which is the smallest value, like the iterator to the smallest value, and then I took the second, which is the count of that smallest value, and I just removed that count from the total size of the array, and that is my answer. Okay, I hope this is clear to everyone. It was an easy question, like good A, I would say. Okay, I hope this is clear. If not, you can let me know in the chat. I'll just explain it again. Okay, cool. Let's move to the problem B now, which I think many people must be like waiting, because there were a few edge cases, I would say. Okay. Okay, cool. So let's look at the problem. Yeah, Ansh, it was too hard. Some edge cases are tough though. Okay, I counted all the elements that are larger than minimum, assuming that he always chooses minimum as subsequence. Yes, Vishesh, that is the answer. Okay. Okay. In problem B, we have a sequence B1 till Bk is called strange if the absolute difference between any pair of its element is greater than or equal to the maximum element of the subsequence. Formally speaking, it's strange if for every pair ij with I less than j less than k, we have ai minus aj greater than equal to max. So basically what they want to say is, let's say we have this till ak. Okay, they say that if we take any ai minus aj, so if we take any random like ai, like any index and any other index, if we like find the difference of these two values and the absolute value of the difference, then this should always be greater than the maximum value. Okay, if this is possible for every pair in this array, then this is a strange array. Okay, now what they want us is that we are given a complete array and we need to find a subsequence out of that array such that every element in that subsequence makes a strange array. So basically that subsequence should be a strange array. Okay, yeah, I think that's the problem. Okay, so if we look at this problem, okay, if we have, let me write the condition at the top. So we have ai minus aj mod should be greater than equal to max. Okay, let's look at what the first test case, which is -1, -2, 0 and 0. Let's find the difference of this -1 with every value. So -2 minus of -1 mod is actually minus minus plus, so we have 1. And what is the like maximum value? Maximum of this array is actually 0. This is greater than 0, greater than equal to 0. Okay, then let's find the difference with 0. So we have 0 minus of -1, this again comes out to be 1, which is greater than 0. Then same for this 0. Okay, now let's try for this -2. So we, for -2 we have 0 minus of -2, and this is actually 2, which is again greater than equal to 0. And then so same for this 0. Then let's try for this 0. So for this 0, 0 minus 0 is actually 0 only, which is actually greater than equal to 0. Therefore we can take this complete array as a subsequence, and this we can say is a strange array. Okay, now let's see like how to solve this problem. I won't like explain all the test cases. Now let's see like how to solve this problem. The very first thing that we need to see is that, let's say we take any two positive values. So we have a1, we have a2, and say both of these are positive. Okay, like positive I mean greater than 0. Okay, now if we find the difference of these two values, if we find a2 minus a1, we know that this difference will always be less than a2, because the minimum value of a1 is 1. We know, because every value is positive, therefore the minimum value of a1 is going to be 1. Therefore the maximum value that this can attain is a2 minus 1, which is actually lesser than a2. This tells us that we can never take two positive values in a subsequence. Okay, so basically now we know that we cannot take, so basically we can take maximum one positive value. Okay, cool. apart from this, now let's see what happens. So basically, if you say, if we have any negative value, okay, and if we subtract this with any negative value and we find this, okay, this will always be greater than both these values. So if this is a1, this is a2, minus a1 and minus a2, then both of these will be greater than equal to a1 and greater than equal to a2, because if you see, the values are actually being added. So if this is negative, if this is negative, the values, okay, sorry, what did I say? Yeah, because we are finding the mod, the total sum becomes greater than any individual value. Okay, reason is because this a1 is negative and this a1 is also negative, and we know that since this is mod, this value will be greater than equal to 0. Okay, and this is extended to like every non-positive value. Okay, every non-positive value, because if we take all the non-positive values in our array, take any two values, the absolute difference of that will be greater than equal to 0, and we know that this difference is always greater than equal to 0. Sorry, the maximum of this is actually at most 0. Okay, so now we know that we can take all the non-positive values in a subsequence and we can take at max one positive value. Okay, now there is still one case missing. Okay, let me show that case. So basically what is missing is, let's say we took -2, -1 and 0. Okay, let's say the positive value that we had was 4. Now if you see, if we try to make this as a like strange array, if we see, okay, let's make this -4. Okay, now if you see, what is the maximum difference that we can get from these values? The maximum difference that we can get from this is actually, sorry, the minimum difference that we can get. So that minimum difference is actually, if you see this difference or this difference is 3 and this difference is 1. Okay, we want that this 3 should be greater than equal to the maximum value, and similarly for this one as well. Now if we are taking any like positive value, then that positive value will become our maximum value. So what we need to do is, we actually need to find the differences of every consecutive value, okay, that we are taking in our subsequence. Okay, and then check if any difference like that every difference should be greater than equal to this max value. Now if we had multiple positive value, let's say we had 4, 6, 8, the very first thing that we will do is we'll actually eliminate all the other values. We know that 4 is the minimum value, and we know that we can take any like at max one positive value only. Therefore we'll remove all the other positive values, we'll consider only the smallest positive value and all the negative and zeros. Now what we'll do is we'll actually find the consecutive difference, because we know that that difference is going to be the minimum. Then we find the minimum out of these differences, and then check if any of this like this difference is less than max. If it is less than max, then we say we cannot include this value. Okay, because if you see in this, the difference is 1 and this one is actually less than 4. Since it is less than 4, therefore we cannot include this 4. But if this 4 had been 1, then we could have said that this one is actually greater than equal to the maximum value. This is the maximum. Okay, if this is greater than equal to 1, then we could have included this one. So basically we need to find the consecutive differences out of these arrays, these values. Okay, find the minimum value and then check if the minimum positive value is less than that. If it is, then we can take this positive value. If it is not, then we cannot take this positive value. Okay, so let me show the code for this now. Okay, okay, I need to open standings, or I can just, okay, so this case was actually like hard to realize. I myself have made 2 wrong summations in this problem. Okay, so if I just copy, okay, if you look at the code now, so basically what I'm doing is, if I'm scanning every value here, now if any of my value is less than equal to 0, then I just push it into the vector. Okay, so I'm taking -4, -4, -1, -0 into a vector, and if it is a positive value, then I am actually trying to take the minimum positive value. Okay, so initially I have initialized this plus to int max. I find the minimum positive value in this plus. Okay, and I also say, so if I ever get a positive value, then I just say that count plus equals to 1, that we have at least one positive value. Okay. Now what I do is I actually sort all these values on the vector. So basically I sort all these values because I need to find the consecutive differences. Okay. Then what I do is I find all the consecutive differences and I find the minimum of all these consecutive differences. Okay. After finding this minimum, which is 1 right here, I check if it is greater than equal to plus. My plus had the minimum positive value. If it is greater than equal to plus, I do v dot size plus count plus. So basically why I'm doing count plus here is because I had to do plus 1 here, but there might be a case that there was no positive value in this array only. If there was no positive value, then we cannot do this plus 1. So basically, if there is any positive value, then only this count plus will be 1. Therefore, I'm just using count plus here. Okay. So if minimum is greater than equal to plus, then we print this. If it is not greater than equal to plus, then we just print the size of this subarray, this array which has all the negative and the zeros. Okay. So there were few edge cases, I would say, which were kind of hard to miss. I myself made 2 wrong submissions. Okay. But I hope it's clear to everyone now. If it is, like, just give a thumbs up to the video so that I know. And you can, like, okay, yeah, cool. And if you're still having any doubts, you can post all your like queries at this Discord channel. I'll be happy to like resolve all of them. Or there are many people, so like it is kind of a community, so like can everybody else can like help each other. Okay, you can find the link at the top of all my submissions. You can just go to Codeforces, find any of my submissions, and you'll find the link. Okay, cool. I hope this is clear to everyone now. Okay, Anupam says thumbs up. Okay, cool. Okay, let's move on to problem C. It was kind of strange that they gave a like problem on graph or like tree in problem C, because I believe there are many people who do not really know like graph in the starting. So this was kind of like something that not many people might have been able to attempt. Okay. Okay, cool. Cool. Okay. Let's start with problem C now. Okay. Are there any people who were able to solve C? I want to get a better idea of like who I am teaching right now. So let's see like how many people were able to solve C, and even D as well. I would like to know like how many people were able to solve either C or D. Okay. In the meanwhile, I'll start the problem. So basically the problem says that parser has a homogeneous tree on n vertices. On each vertex V, he has written 2 integers L and V. To make parser's tree look even more majestic, Nemo wants to assign a number AB. So basically what they're saying is we have a tree, and for every node we have either like we have values either LV or RV. Okay. Then Nemo's sense of the beauty is rather bizarre. He defines the beauty of the tree as a sum of AU minus AB over all the edges. Okay. So what we have is we have a tree, and in every node we can either take LV or RV. Okay. Now to find the beauty of the complete tree, what we need to do is we need to look at every edge, find the value that both the nodes connected to this edge have, and find the absolute difference of that and add it to the beauty. Okay. Now parser wants that we should have the maximum beauty. Okay. So that is all we have to do. If we look at the constraint, the size of the tree is 10 to the power 5. So let's try to make the first problem. So if you see, the input is actually like this. We have 2 nodes in the first problem. We have 1 connected with 2. So if you like, let me explain the input format. So basically there are 3 number of test cases. 2 is the number of nodes. Then for node 1, the values are 1 and 6. For node 2, the values are 3 and 8. So basically for node 1, the values are 1 or 6. For node 2, we have 3 or 8. Okay. And this is actually the edge. So we have an edge from 1 to 2. Okay, cool. So if you see, we actually need to run a brute force in this problem. Okay, let's first try to solve this problem. So we know that what are all the cases that we can have. If we take 1, so for this one, if we take this one, then there are 2 cases. 2 might take 3 or 2 might take 8. If we take 6, there are 2 cases again, that 2 might take 3 or 2 might take 8. The difference of this is 3 minus 1 is 2, 8 minus 1 is 7, 6 minus 3 is 3, and 8 minus 6 is 2. We can see that this 7 is the maximum value, and therefore this 7 is the answer. Okay, let's move to, like, let me just show the next example as well. Okay, okay, yeah. Okay, so in the next example, we know that there are three nodes, 1, 2, and 3. For 1, the values are 1 and 3. For 2, the values are 4 and 6. For 3, the values are 7 and 9. Okay, now let's make the edges. We have an edge from 1 to 2, and we have an edge from 2 to 3. Okay, now, okay, let's try to do something. Okay, so for 3, we have 7 and 9. For 2, we have 4 and 6. And for 1, we have 1 and 3. Okay, now as you can see, the best answer for this is actually, if we take 1 for this one, for 2 we take 4, and for 3 we take 9. This has a difference of 5, and this has a difference of 3, and 3 plus 5 is actually 8, which is the answer. Now, how to find this answer? Let's see. So basically what we want is, we actually want to, like, do a brute force on this. Okay, now in order to do a brute force, let's start from this 3. If we have this 3, we come on to this 2, and we say that this 2 has 2 options, like 4 options actually. If we can take 4 here, then this 3 can take either 7 or 9. If we take 6 here, okay, if we take 6 here, this 3 again says that I have 2 options, either take 7 or either take 9. Now when we come on to this one says that I have 2 options, I can either take 1 or 3. It says that we might have a case when I take 1. If I take 1, I know that there were 2, like, possible combinations from this 2, which were 4, 7, 4, 9. Okay, let me, like, draw these like this. Okay, so, like, one case was 4, 6, the other case was 4, 7. Sorry, this was 4, 7, this was 4, 9. Okay, the other case was 6, 7, and the last case was 6, 9. Okay, now this one says that I can actually attach myself to all these. Okay, so basically by attaching, I mean that one option is 147, one option is 149, the other option is 167, and the last option is 169. And similarly for 3 as well, we might have, instead of this 3, we might take a 3. Instead of this one, we might take a 3, and here also, and here also. Okay, and then we can count the differences. Now what we need to do is, we first try to find the maximum value for this 2. For this 2, I mean, what is the maximum sum this 2 is able to get if we take 4, and what is the maximum sum we are able to get if we take 6. So basically what I'm trying to say is that, if we say that we were on node 2 and we asked node 2 to take 4. Okay, now this 4 said that I have 2 options, I can either attach myself to 7 or I can attach myself to 9. I know that 4 minus 9 is 5 and bigger than this 3, therefore I'll take 9. So this 2, 4 says that the best answer for me is actually taking 9, and the difference will be 5. Okay, right now let's just forget that we have this node as well. Okay, now it says that, what about I am node 2 and I try to take 6. If I take 6, I have 2 options, I can either take 6, 7 or I can have 6, 9. This has a difference of 1 and this has a difference of 3. Now the maximum out of these is 3, so I'll write 3 here. Now let's come on to this one. This one says that I have 2 options, I can either take 1 or I can take 3. Let's go with 1. So basically 1 says that I am node number 1 and I am taking 1 with me. If I take 1, I know that I have 2 options, either 2 can have 4 or 6. If 2 had 4, okay, if 2 had 4, then my beauty would be 1 minus, like, 4 minus 1. Okay, since we are taking absolute, 4 minus 1 plus the beauty that it was able to take below the tree, which is 5. This value is actually 4 minus 1, 3 plus 5, 8. Now this says that I had another option, which was I connect myself with this 6. Okay, so the difference will be 6 minus 1, and the beauty that this 6 was able to acquire below itself was 3, so we add this 3 as well. This gives us 5 plus 1, that is again what, 5 plus 3, that is 8. Are these values same? Like, we have 3 plus Okay, yeah, both of them are same. Okay, cool. Okay, I hope everything is right. 6 minus 1 is 5 plus 3. Yeah, cool. Okay, so this is also 8. Okay, so one says that since both of them gave 8, one says that the maximum value I can get using 1 is 8. This one says that I have another option, which is I can actually take 3 with me. Okay, if I take 3 with me, okay, I can attach myself with this 4. Okay, if I attach myself with this 4, the difference of beauties will be 4 minus 3, 4 minus 3, okay, plus the beauty this 4 was able to acquire below itself, which was 5. So this is 1 plus 5, which is actually 6. And this 3 says that I can even attach myself to this 6. If I attach myself with this 6, I get 6 minus 3 plus the beauty it was able to acquire below itself, which was 3. Okay, so this is 6 minus 3 is 3 plus 3. This is again 6, which is very strange. Okay, so we have 6 and 6. Maximum is 6 only. So we say that if we take 3, the maximum beauty we can get is 6. Now, since every node is processed, we say that the maximum value will be either this 8 or 6. And since 8 is like greater, we say that 8 is the answer. Okay, so I hope you're able to see the state. So basically for every node, we had n nodes. I'm actually trying to take both the parts, left part. Okay, let's not call it left. What do we say? Like L or R. I try to like assume if I take this node with L, what is the maximum beauty I can get below myself? And if I try to take this R, what is the maximum beauty I can get below myself? Okay, so how to like visualize this now? Let's say I had my tree, which was this. Okay, we already know that this is a tree. Let's say this was the tree. Let's say that this node first was able to find out the maximum value it had below itself, which is actually 0, and similarly for the 0. Now this node will say I have an L and I have an R. I will try my L with all the values of this and find out the maximum like beauty. And similarly, this R will also say I will try to find all the values with this node and find the maximum value, and I'll add for this node. So basically, let's say the maximum value. Okay, let me draw this a little bigger. Okay, so let's say my tree was this. Okay, this was my tree. Now we know that the answer for this is 0 and for this is also 0, because there is no tree below this. Okay, so or we can say there is no edge below this. Okay, now this says that I have an L and I have an R, and this also says that I had L, R, L and R. I will first try to take myself with this L, then I'll try to take myself with this R and find the maximum answer. Let's say the maximum answer was answer 1. Then this R says that I will also try to find my maximum difference with this L and this R, and let's say that difference was answer 2. Now we can either take L or we can take R. Okay, similarly for this as well, this will say that I'll actually try to find out the maximum sum with this L and my maximum sum with this R. Let's call them answer 3 and answer 4. Okay, so what we'll do is we'll actually find the maximum out of these two values. Okay, so maximum of these two values and the maximum of these two values. The maximum of these two values is the sum that it is going to get from this edge, and the maximum of these two values is the sum that it is going to get from this edge. We add both these values and let's say we call that sum. Now we know that this node can get a beauty of this sum below itself if it takes this L. So we have two sums basically, sum 1 and sum 2. Sum 1 is when it takes this L and sum 2 is when it takes this R. Similarly, now this node will say I can either take L or R. If I take this L with this L, I will find the distance of this L and L and add sum 1, because we know that if we take this L, the sum 1 is also like taken from the beauty below the tree. And similarly for this R also, we'll consider both the values. Now you know, like, so basically this can easily be done using a DFS. Now the problem comes that how to minimize the values, because we like the number of states will be a lot. If you see, for this node we had L and R. So what we were actually doing is, let's say beauty of this node, let's call this node as x. Beauty of this x is actually like the maximum value, okay, beauty L and beauty R with x. Beauty L is when we take L for this node, the beauty it is able to get from below itself, and beauty R is the beauty it is going to get if we fix R for this node, okay, and some of these values. Now this L says that if I take myself, okay, let's call this L1 R1 and let's call this L2 R2. This L2 says that if I take myself, I'll have L2 minus L1 absolute value plus beauty L of x, beauty L of x, because I have fixed L for this one. Or my value could be L2 minus R1 plus, okay, I'm just removing this, beauty R with x. Okay, it will find the maximum out of these values and return the value for this L2. This will become beauty L2 for this particular y. Let's say this is y. Okay. There can be 3 leaf nodes as well. That is not going to bring any difference. Okay, you will like see like what I'm trying to say. Okay, then this R2 comes. This R2 says that if I take this L1, I'll have R2 minus L1 plus beauty of L1. Sorry, beauty of L, which is L for node X. If I take this R1, then I'll have R2 minus R1 plus beauty R of X. If you see, this beauty L is equal to this beauty L and this beauty R is equal to this beauty R. So you can see that these states are actually being repeated. So if we find the value of this beauty L once, we can actually use the same value here. Okay. And similarly for R as well. Okay, so like I hope this is clear to everyone now. This is a very basic DFS, and in that DFS we are actually memorizing every value. So let me like open the code and like try to explain this thing. Okay. Okay, let's look at the code. So basically what I'm doing is I have actually made a map. Okay, this map is actually has a pair as its key. So basically in its key I have a pair of, and this pair is actually nothing but m of, so basically this is the node which I'm taking, and then I have either left here or right, just to show which direction I am taking. Okay, let me even like remove this. This is not required. Okay, cool. So basically what I'm trying to say is, okay, so what I do is I have this map. In this map I'm storing all the states. So if I'm at this X, and if I take, so basically beauty L will be represented as X comma L1, beauty R will be represented as X comma R1. Okay, so basically what we're doing is I just like I am taking L1 and R1 as left one and right one. Okay, so I'm scanning all the left and right values, I'm clearing all the edges. Then what I do is I have scanned all the edges and inserted them. Then I just run a maximum of DFS. We know that both the trees are rooted at, like the tree is rooted at 1, or even if it is not rooted, we can assume it is rooted at 1. Okay, then what I do is I call for left of this value and I call for this right. What I'm trying to say is that I fix L here and then try to find the complete sum of the beauties. And in the other case, I try to fix R and then try to find the sum of all the beauties. Okay, so I run for all the cases, like both the cases, and find the maximum value and print. Now what is happening in DFS? If you see in DFS, the very first thing that I check is if this state has already occurred. Now the order to do that is this start contains the node and this value contains the value of left or right which I have taken. Okay, so basically if you see, I have the node number and the value. Okay, and the 0 is the parent. Okay, so basically what I'm doing is I'm checking if start comma value was already present in this DP. If it was present, I just return its value. If it was not present, what I do is I actually run this for all its edges. So basically, like someone said, Vishwesh said that can there be 3 leaves? If this had 3 leaves, I actually run this for every node which is like in its child. Okay, and then I find the value. So basically this is when fx left and this is when fx right for this particular node. Okay, if fx left I get some value, if fx right I get some value. I find the maximum out of these and I add it to the sum. So basically for this sum I'm trying to find the maximum value it gets from this side and this side. Okay, and in the end I just like put this value in my DP start of this because this is the value that I'm getting for this node. Okay, I hope this was not very confusing for everyone. It's hard to like explain like how this DP works, but yeah, it's easier to visualize. So what you have to do is you just have to assume that you have the values of all the subsequent values that you need. Okay, so you just try to think for that particular node, what are the states it is going to require, and then call all those states and everything else will take care of itself. So basically in a DP, there are 2 things. The first is like, what do we say? The base condition. Okay, then we have the recurrence, and then we have then we have the recurrence. Okay, so we have the base condition and then we have the recurrence, and then we sometimes have the return values or something. Okay, so that is, so basically this was the like condition that we need to check, like if this has already been occurred. If it has, we just return the values and then we call all the recurrence. Okay, so I hope this is also clear to everyone. Okay, I'll just submit this code. Okay, because I submitted a different code, the previous one. Okay, cool. Let's move on to problem D now. Okay, this is accepted. Cool. Okay, you can just like check my submissions if someone wants to see my code. And one more thing, so basically I have a Discord channel. So if anyone wants to, where is the channel? Okay, this is the link. In every code I have this link on the top. So if anyone wants to ask me anything or something, you can join the Discord channel and you can ask me there. Okay, yeah, it's kind of DP on trees. Okay, so let's move on to problem D now. To be honest, I feel D should have been C and C should have been D, because there are many people who do not really know like how to like run DFS and everything, and like then having variations in a DFS is something that not many people, like many starting people, do not know. But D actually required no knowledge of anything. Okay, except like how to find divisors. Okay, so I think like D should have been C, and maybe submissions for, okay, no. Okay, cool. Let's move on to problem D. So in problem D, we have Kavi has 2 endpoints lying on the OX axis, ith of which is located x equals to I. So basically, if n is, let's say, 2, then that means we have 4 points. And the 4 points are, this is 1, this is 2, this is 3, and this is 4. Now Kavi considers all ways to split those 3. Okay, I'll just skip the problem and I'll like explain what they are trying to say. So basically they want us to make n pairs. Now they want that every pair from every other pair should hold a relationship, and that relationship should be either pair 1 and pair 2 should be completely, so either of them should be completely inside. So if you look at the very first image, you can see that this pair is actually completely inside the other pair. Okay, or both of them should have the same length. So basically if you see in this one, this has the same length with this one, but we cannot have this as a good pairing. The reason is because this pair has an equal length with this pair, but this pair does not like have a similar length with the blue line, and this does not even inside, this is not inside the blue line as well. Okay, so basically we want that every like pair should either be inside or they should have the same length. Okay, so for 4, let's see all the possible options for 4. So if we look at 4, so basically we have 2 cases only. Like if n is 1, if n equals to 1, then there is 1 case only, because there is only 1 pair possible. Okay, then let's move on to n equals to 2. If n is 2, there are 3 pairs possible. Let's look at those pairs. So basically the very first pairing would be if we take this and this. The second pairing would be if we take this and if we take this, because in the previous one, if you saw, we had 2 pairings and both the pairings had a length of 1. In the second pairing, we had 2 pairs and every pair had a length of 2. Now in the third type of pairing, we can actually have this as this and this. If you see, there are only 2 pairs and the second pair is lying inside the first pair. Okay. Now let's move on to what? Let's move on to n equals to 6. If n is equals to 6, let's draw this. If n is equals to 6. Okay, 1, 2, 3, 4, 5 and 6. So we have 1, 2, 3, 4, 5 and 6. Now let's see. Let's start with the maximum length of pairing that we can do. The maximum length of pairing that we can do is this. Okay, now let's see something. Let's just say that this is one pairing. That means every other pairing that we do will actually be present in this. And if we see, there are 4 like nodes here. Okay, so basically this actually, okay. So every pairing will be in this. Okay, and these are actually 4 nodes, like 4 points, which is actually the case of n equals to 2. If we take any combination in this, which was an answer of n equals to 2, so basically which was an answer of this, we know that since we are taking answer of like 2, every pairing in answer of 2 is already balanced. Like every pairing of answer 2 is already following the rules. Okay, and this pair, so basically this pair needs to follow the rule with every other pair of answer 2. If you see, this is actually covering all the pairs. This is actually covering all the pairs that are present in answer 2. So according to rule 1, we can say that this pair is valid and every other pair that was present in this was already valid because that was the answer of 2. So basically we can say that for n equals to 3, this is n equals to 3. For n equals to 3, the answer will be answer of 2 plus. Now what is the next thing that we can take? I'll just rub all of this and draw this again. Okay, if we see, we have 1, 2, 3, 4, 5 and 6. The next way we can do is we can actually have this and we can have this, and then we are actually left with one, like these many values, which is 2, like not 2 points, which is actually the case of n equals to 1. And as you can see, this pairing and this pairing have equal length, so therefore these two are satisfying each other, and every pair that is found in this length is actually present under this length also and this length also. So all the pairings will be valid. So basically, if you see, this is nothing but the answer of 1. Okay, now let's try to extend this idea a little further. Now if you see, we had 1, 2, 3, 4, 5 and 6. Now we know that we cannot extend this further, because if we make this and this, then no pairing will be left. Okay, what we try to do is we actually try to see that we know we have 6 points. What are the total number of ways we can actually divide the 6 into equal parts? What I mean by that is because that, so if we had this 1, 2, 3, 4, 5 and 6, one way would be we actually fix the length of every pairing as 1. What I mean by that is, this is one pairing, this is second pairing, this is third pairing. The next case would be if we actually fix the length of every pairing as 2. If I fix the length of every pairing as 2, I can actually make this as a pair, then I can make this as a pair, and then I can make this as a pair. Okay, so you can see for length 2 also it is possible. Now let's try for length 3. If we try to for length 3, okay, I actually, okay, just a second. Okay, I actually by mistake made for length 3, I think. Okay, just a second. So basically when I made, okay, when I made this has a length of 3. So let's remove this. For length 3 also we saw that it is possible. For length 1 also we saw that it's possible. Now let's try for length 2. Okay, when I try this for length 2, 1, 2, 3, 4, 5 and 6. This is length 2. Now I know that, let me even show you these. Okay, these will help. So if we see, we are already done with everything which had a like length of 5. That was answer 2 and answer 1. So basically we have already covered this. We have already covered this case. We have already covered this case. And we have also covered which one? This case as well. Now the leftover cases are this one and this one, which are already covered by this and this. So if we try for length 2, you see that this will make a length 2. Then the next pairing that we make is this. Now the third pairing cannot be made because this will have a length of 1. So we see that we can only make length of 1 and length 3. Okay. So let's say we had 8 points now. Let's try to solve for 8 points. Okay. So we have 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now if you see, the very first thing that we can do is we can actually have this bigger one, and now we can actually reduce this problem to n of, so now we are considering n equals to 4, n of 3. Okay, so we can say that answer of 3 will be a part of n equals to 4. The next thing we can do is we can try to make a length of n minus 1. Now this actually reduces to this one, which is n equals to 2. So we can say that we need to add answer of 2 as well. Okay, now let's try it one more. When we make this, this and this, we are left with this one, which is actually under every of these pairs, and all these pairs have equal length. Okay, so this is also possible, and this is actually n equals to 1. So we add answer of n equals to 1. Now we have already done length 7, we have done length 6, we have done length 5. Now let's try length 4. If we try length 4, you see that this goes here, this goes here, this goes here, and this goes here. So that is one case. So we add plus 1 for length 4. Now let's try for length 3. If we try for length 3, you see that this is a possible, this is possible, this is possible. Now the last pairing will be this, which is not equal to the length of all the other pairs. Okay, so this is not possible. So length 3 is not possible. Now let's try for length 2. If we try for length 2, we have this, and then, okay, so basically this. Now we still have 4 left, so we can do it like this. So length 2 is also possible. And similarly for length 1. If we try for length 1, we have this, and this. So that is also possible. So we need to write plus 1 for length 2, and for n equals to 1 also we need to write plus 1. If you see, we were able to find lengths of 4, 2 and 1, which are actually divisors of this 4, which is actually logical. So basically we wanted to divide the complete length into equal pairs. To do that, only the divisors will be able to do that, because the divisors will only be able to divide this number line equally. Okay, so basically if this is 8, for 4 only we will be able to equalize this, for 2 only we will be able to equalize it like this, and for 1 we will be able to equalize it like this. Okay, so that is the theory behind it. So basically what we need to do is for n equals to 4, we need to find the sum of all the previous answers, and then we need to find the total number of divisors that this 4 has. Okay, so I hope this is clear to everyone now. Okay, and similarly for like if we have n equals to 5, so n equals to 5 will be answer of 4 plus answer of 3 plus answer of 2 plus answer of 1 plus number of divisors of 5. 5 has 1 and 5 as divisor, so therefore plus 2. Okay, similarly for 6 also. So basically sum of all these values plus n equals to 5 plus all the divisors of 6, which are 1, 2, 3 and 6. So basically plus 4. Okay, so this is the logic. Let me show my code if someone wants to see. So basically the only thing that we have to do is we actually need to find all the divisors beforehand now. Okay, so that we do not get a time limit. Okay, so if you see, what I am doing is I am just finding the sum of all the divisors, or the total number of divisors here. Okay, and then like find this sum actually contains the sum of all the previous values. Okay, and then I'm adding the total number of divisors. The reason why I have done plus 1 here is because my divisor count is actually 1 less than that, because I'm not considering 1 as a divisor. Okay, therefore I have to explicitly add plus 1. But yeah, if you have a code which works in a different sense, then you don't need this plus 1. Okay, so basically this is all I'm doing. I'm just like finding the sum of all the previous answers, adding it with the divisors of this particular I, and then plus 1. Okay, yeah. So I hope this is also clear to everyone. This was also like a good question, I would say, for problem D. Okay, so we are done with problem A, B, C and D, and I hope it is clear to everyone. Ashwini says was able to solve till C today. That's really nice. If you're able to solve C, I would say like you are getting better. Okay, all right. Okay, I think it's time. We are already like the stream has already been of 56 minutes. I think that's enough for today. Just like the video if you like the stream and you're liking all these streams of up solving the contest right after the contest. If you have any suggestions, you can just comment anything, or you can even tell me on my Discord server. Okay, and the next contest is on I think it's on 26th. 26th. Okay, this is a 4-day contest. Okay, so this is not, we are not going to cover this. The next contest is on 28th, so make sure you give this contest. And again, like on 28th, it is starting on what, 7:35. So I'll probably come live at 10 p.m. and we'll upsolve all the problems. Although this is a contest of 2.5 hours, so I think this will be a little difficult. But anyways, yeah, so let's meet on 28th. We also have lunchtime approaching, so make sure you give that as well. Okay,